Hey, last kind of stuff for the entire year going on here. So, I mean, way to go. Um, and here we're going to look at a little bit more volume stuff, just kind of reviewing on that, but we're going to look at cones and spheres. That's what they're called. I couldn't think of that word for a second. But cones and spheres are what we're going to look at today. I did attach a second video on here. I think it's a very good one if you want to see why those formulas kind of work out the way they do, or you want to see that actually in action. We're going to go through why that works a little bit here. But you can go ahead and watch that video. He kind of shows, oh yeah, actually that many do fit in there. He just kind of uses that with a little bit of water and stuff to see. But if you watch through that video, kind of what he shows is that you can actually take three cones and fit them into a cylinder of the same size. The circle would be the same size on here. The height would be the same. The only difference is that the cone comes together as a point. Okay. So you could actually fit three of those. Now, here's where the piece comes. We know the formula for the volume of a cylinder. The volume of a cylinder is the circle on top, right? We'd have pi r squared times the height. Okay? You guys know that that's what that one is from the other day. Like that's what you guys did when you were finding volumes yesterday of cylinders. We'll see if this pops up here in a second. But for a cone, since it is exactly three of these fit in here, the cone has to be exactly 1/3 of this. So what we would do is we would take this thing and divide it by 3. And that is the formula for the volume of a cone. Pi r squared times the height, which the height a little bit different than before. Before, when we talked about surface area, we talked about the slant height. This would be the height going from the very point straight through. So it's slightly different there, but we'd have the height and then times the pi r squared divided by 3. That's what the formula is for a cone. Okay, to look at an example of how we would utilize that, and here again, I put my example. I would have to write that down. I don't always remember what that is, but I'd need to find, okay, what's the radius of the circle? Remember, radius is only halfway across. The height here is 12, okay? So that means that the volume in this piece here, I'm going to shorten these up just a little bit so we have some room to write the volume. The volume in here would then be pi times radius squared times the height divided by, now I don't have a divided by symbol, so I'm just going to put a /3. Okay? And now again, just as before, you can go ahead and leave these things in terms of pi if you would like. Here's 25 times, well, 12 divided by 3 is 4. So if you want, you could leave this as 100 pi. If you want to go ahead and put that into decimal form, you can do that as well. But it's perfectly fine if you want to leave it in terms of pi as well. That's okay to do. All right, so that's using a cone. We're going to pop back up here for a second. Again, if you watch the video through, what you'll find, what he shows is that actually you can fit two cones. If you make them kind of the same height as the sphere, and they will fill up a sphere. Okay, two cones, exactly two cones, fit inside of a sphere. So if we kind of follow through that logic a little bit here with the formulas, this is one cone. So if we wanted to double that, so I'm going to put that in here, here's one cone. If we wanted two cones, right, well, that would be two of these things, right? Which seems kind of weird for a sphere, right? This doesn't exactly work out because a sphere, you would say, oh, sure, take 2 times pi times the radius squared times the height, which, oh man, what's the height of a sphere? Well, the height of a sphere would be from the very top to the very bottom. The height is the same as, right, double the radius. So if I took this thing, right, and put this down, the height here is the same as 2 times the radius. Okay, and then what we could do here is clean this up just a little bit. Here we have a 2 times 2. 2 times 2 is 4. That's what that is. And then we've got radius squared and another radius. So that would be radius cubed. And that, in fact, is the formula for that. Whoops, I didn't want to take that whole thing out, but that's okay. And that is how we have the formula of a cube, or sorry, not cube, sphere. Formula for a sphere is 4 pi r cubed divided by 3. So you just kind of utilize that formula. Okay, so here's a quick example of that. If I saw this, I would say, okay, I want to take the radius, which in this case is 5. And so the volume is going to be a little bit funkier. I got to give myself a little bit more room to work because I need a little bit more space. I'm going to change the size of this a little. So we'd need 4 times pi, whoops, times the radius cubed, so that's 5 to the 3rd power, and then divided by 3. Okay, so I got a few things to work out there. So in this case, what I would do is I'd have to jump to my calculator. I have to do 4 times 5 cubed, which I think is 125, and then divided by 3. And what we get is 500. That's 4 times 5 cubed. And I'm going to put my pi in there, divided by 3. Now that's okay. If you want to leave, this is in terms of pi. You cannot reduce 500 over 3 anymore. That's okay. If you wanted to, we could type that into a calculator and do 500 pi divided by 3 and say, oh yeah, you know, that's about 523.5, oops, 60 if I round that a little bit. So you can always change that, but you can leave it right here in this type of answer right here would be also just as good. And so that is how you'd find volume of stuff. Remember, I'm releasing all of this stuff right, on Monday, but these things just need to be turned in all by Friday or any other late work, so that you guys make sure you have credit for that beforehand. So if you guys have any questions, let me know. Otherwise, have a good summer.